So next we are studying the different types of velocities of gas molecules. Already I think yesterday only we have studied these velocities in states of matter. No? In KTG also we have to study them. Okay? RMS velocity. What is meant by RMS velocity? Root, mean, square. Velocities are called as RMS velocities. Okay? For example, if molecules are having velocities v1, v2, v3 like this, many velocities are there up to vn, okay ma? Then how can I calculate RMS velocity? This is equals to square root of v1 square plus v2 square plus v3 square plus dash dash vn square divided by m. So this is how we can calculate RMS velocity of gas molecules. Already we discussed, no ma? So R means root. Root is given, no? Mean means we are taking the average, no? Average of which velocity is square of velocities. It means v1 square, v2 square, v3 square. So that is called root mean square velocity, RMS velocity. Okay? And there are many methods in which we can write equations of RMS velocity. First one I can write, so this is the first equation. Second equation I can write, Vrms is equals to square root of 3RT divided by capital M. I can write like this. Okay? And what is meant by capital M? Capital M is the mass of 1 mole of particles. Okay? Or you can call them as molar mass. Or you can call it as molecular weight. Anything you can call it. Okay? So this is one formula. Square root of 3RT divided by capital M. And second one, third one, already we know that K is equals to R by Na. This relation we know, where K is called as Boltzmann constant. Understood, Doma? So therefore R can be written as K into Na. K into Boltzmann constant multiplied by Avogadro number. So just substitute instead of R, you substitute K into Na. So then I will get another equation. So this is equals to square root of 3K NaT divided by capital M. Understood, no? Now what I do is I will write Vrms is equals to square root of 3KT divided by M divided by Na. I can write like this, no? What is M here? Capital M is the mass of 1 mole of molecules. It means Avogadro number of molecules. Clear? So that mass, if I divide by Na, then I will get the mass of single molecule or single atom or single ion. Therefore what I can write Vrms is equals to square root of 3KT divided by M naught, small m naught. Okay, ma? What is small m naught? It is mass of single molecule or single atom, anything you can call it. Okay? This is another equation, Vrms. Okay? Let us see one more equation, fourth equation. Okay, ma? So Vrms can be written as square root of 3RT divided by M. Okay? And this is the mass of single mole, no ma? I will write ideal gas equation, PV is equal to nRT. So if number of moles are taken 1, then PV is equal to RT. So therefore Vrms can be written as square root of 3PV divided by capital M. This is one more equation. Are you able to understand, ma? Another equation I can write a fifth equation from this fourth equation. Vrms is equals to 3P divided by mass divided by volume. Volume is in numerator, Loma. I will take it as a denominator to denominator, which becomes numerator. Okay? Mass by volume is called density of the gas. So therefore I will write Vrms is equals to square root of 3P divided by rho, where rho is called as density of gas. Clear, ma? So where rho is called as the density of the gas. This is one equation. And one more equation I can write in terms of kinetic energy of gas also. Okay, ma? So kinetic energy of gas molecule I can write, it is equals to half m Rms square. I can write like this. Okay, ma? So half mv Rms square. Kinetic energy given by kinetic energy is equals to half mv Rms square only, no ma? Therefore what I can write? Therefore I can write Vrms is equals to square root of 2k divided by m. So this is one more equation to calculate RMS velocity of the gas, where K is called as kinetic energy of single gas molecule. Okay? K is called what here? K is kinetic energy of single gas molecule. Okay, so these many equations we can write for RMS velocity. Okay, and what was the second velocity we have studied in states of matter? Average velocity. So how can you write average velocity? Average velocity, how can I write? Just instead of 3, wherever you find a 3, you substitute that value by 8 by pi. Then it converts into average velocity. Okay, so write down. Clear, ma? So second type of velocity is average velocity. Okay, ma? So average velocity. First of all, let us see what is the meaning of average velocity. For example, if I have v1, v2, v3 and it goes on, clear number? So vn velocities are present. Okay. So therefore, average, how can I calculate? Average is equals to v1 plus v2 plus v3 up to vn divided by n. This is how I can calculate average velocity. Understood, no? And one more method is that general equation wise, how can I write? In equation of, or in equations of Vrms, substitute 8 by pi instead of what? Instead of 3, then those velocities they convert into average velocities. Clear number? So V average is equals to, instead of 3, what I have to write? 8 by pi. Clear number? Similarly, you substitute remaining all the values. So here also, instead of 3, 8 divided by pi. It converts into average velocity. Okay, ma? So average. So here also 8 by pi. So here also average. So 8 divided by pi. So everywhere you have to write the same values now. Average 8 by pi. Okay. Average 8 by pi. Average 8 by pi. Okay. And this one is not satisfied. Sixth one is not satisfied. Okay, ma? So these are the equations of average velocity. Understood, no? And what is the third type of velocity which we have studied, ma? One more velocity we have studied, no? What is that? Most probable velocity. So write down the third one. So most probable velocity. What is meant by most probable velocity? Already we have studied, no? What is that? For example, if velocities of gas molecules are 1, 2, 2, 3, 3, 3, 4, 4, 4, 4, 5, 5, 6, 6, 6. Okay. Then out of this different velocities, which is the most probable velocity? 4, because it is repeated many number of times. No? That is called as most probable velocity. Okay, ma? So the velocity of most of the molecules, velocity of most of the molecules is called as most probable velocity. And what are the equations of most probable velocity? Instead of RMS velocity in 3, we substitute 2. Just instead of 3, if you substitute 2 in all the equations of RMS velocity, they convert into most probable velocity. Understood, no? So VMP, most probable, is equals to, instead of 8 by pi, we are supposed to write 2. 2 RT divided by M. Now remaining all values also you can change, no? So wherever you find average, you convert into most probable. Wherever you find 8 by pi, convert them into 2. Clear? That's it. So this is the given question. 2 molecules of gas have different speeds, ma? They have speeds of 9 into 10 power 6 and 1 into 10 power 6 meter per second. Then what is the RMS speeds of these molecules? Okay. What is the method of calculating RMS speeds if two different velocities are given? Vrms is equals to square root of V1 square plus V2 square divided by 2. That's it. Clear now? Oh, ma? I don't think. Okay, ma? So Vrms is equals to square root of one velocity is 9 into 10 power 6 whole 10 power 6 whole square plus velocity of second particle is this much divided by 2. Clear now? So if you do this calculation, the answer which you should get is RMS velocity is equals to root 41 into 10 power 6 meters per second. That is the RMS velocity of the gas. Clear? So see this question. Two molecules of given mass of a gas have RMS speeds of 100 and at 27 degrees Celsius and 1 atmospheric pressure. Okay, ma? Then what is the RMS speeds of gas molecules at 127 degrees Celsius and 2 atmospheric pressure? Are you able to understand? So therefore, there are two molecules, their RMS speeds are 100. At which temperature? At 27 and 1 atmospheric pressure. So question is given on temperature and speed and pressure, so I will take this equation. Vrms is equals to square root of 3RT divided by capital M. This is what I can write now. Are you able to understand, ma? So in this equation, pressure, is it present? Pressure is not there. So what do you understand? What do you understand? RMS speed does not depend on pressure. That is the point which you should understand by looking at the equation. RMS speed depends only on temperature. Whatever may be the pressure increases or decreases, but RMS speed is never going to change. Are you able to understand? So therefore what I write? I will write that Vrms is proportional to root T. Or you can write Vrms square is proportional to 2T. That's it. So there is no effect of pressure on Vrms. Are you able to understand, ma? So here mass of the gas remains same. R is a constant. Clear, ma? So therefore how can I write a relation? I can write Vrms 1 divided by Vrms 2 is equals to what I can write? I can write square root of T1 divided by T2. This is what I can write now. If I want RMS 2, I will do one thing. I will write 2 divided by 1. That is better. Okay, ma? So therefore, now just do the calculation. Vrms 2 is equals to Vrms 1 multiplied by T2 divided by T1. Just do this calculation. So Vrms 2 is equals to Vrms 1 is 100, no, ma? So 100 multiplied by square root of final temperature is how much? Final temperature he said 127. So 127 plus 273. And here you should not forget to convert into Kelvin scale. Because here a capital T is mentioned, no? It means we are supposed to substitute the temperatures in Kelvin scale. So divided by initial temperature was how much? 27. 27 plus 273. So therefore RMS speed, final RMS speed is equals to 100 multiplied by square root of how much is this one? 400. 400 divided by 300. So 0, 0 get cancelled. So therefore what I will get? 2 by root 3 multiplied by 100 meters per second. That is my answer. That's it. Clear? Okay, ma? So see this question. So figure shows a vessel partitioned by fixed diathermic separator, ma? So different ideal gases are filled in two parts. Here there is one ideal gas, here there is one more ideal gas. So RMS speeds of these molecules on one side, it is equal to mean speed means average speed, mean speed of molecules on the other side. It means here I consider here let velocity of the gas molecules if I take Vrms velocity, and here if I take average velocity, these two are equal, he is saying. Clear, no? Then what is the ratio of mass of these molecules which are present on both sides? Okay. It means he is asking us to find out M1 divided by M2 ratio. Okay. Here different molecules are there, here different molecules are there. No? So here mass of each molecule, let it be M1. And here mass of each molecule, let it be M2. This ratio I am supposed to calculate. And here the information which he gave is it is a diathermic separator. Walls are of two types, already we studied, no ma? Walls are of two types. What are they? One is a diathermic wall and the second one is adiabatic wall. Clear? What can diathermic wall do? It can easily transfer heat energy from one surface to another surface, or across this separator heat energy can travel. But what is meant by adiabatic wall? Here the transfer of heat energy is how much? Zero. Heat energy cannot transfer. So because this is a diathermic separator, and if there is any temperature difference, definitely heat will travel to the other side, no? And this transfer of heat will continue up to which position? Until temperatures become equal. Are you able to understand? So therefore I can see that temperatures on both sides of the gas, they must be equal, because wall is a diathermic wall. Okay, ma? Therefore what I can say, temperatures on both sides must be equal. Okay. So therefore if temperatures are equal and if these velocities, RMS velocity and average velocity, they are also equal, just equate them. So V RMS is equals to V average velocity. What is the equation of RMS velocity? Square root of 3 kT divided by small m, or m1. Why I am taking 3 kT by m1 ma? I can take 3 RT by capital M also, no? He is asking to take only mass of single molecule, no? Mass of single molecule ratio he is asking. And that I can get only in this equation. RMS velocity also I can write V RMS is equals to square root of 3 RT divided by capital M also I can write, no? But what is this capital M? Mass of 1 mole of molecules. But that is not what he is asking, no? He is asking mass of single molecule present on one side to the other side. Okay. So this is equals to, what is the equation of average velocity? 8 by pi kT divided by mass of the second molecule is m2. Mass of the molecule on the other side is m2. That's it. This is what I want to calculate. So just you cancel the roots, roots can be cancelled. Kt can be cancelled. And therefore what I will get? 3 by m1 is equals to 8 by pi multiplied by 1 by m2. Okay, ma? So if I take the ratio of m1 divided by n2, then it is 3 pi divided by 8. That is our answer. Okay? Root cheppinavu.